Well, if you're anything like me, you may have looked into history a little bit related to, electronics and electromagnetics. And you might have noticed condensers and capacitors. Now, what's very interesting is we are told that in the old days they called them a condenser, but now we call it a capacitor, and we've just got a slightly different symbol. But I'm going to prove to you that they are not the same devices. They behave differently, and I'm going to use well-known laws of physics to prove these points, and these laws are Faraday's laws of induction. So, a capacitor, as you would know, and if you don't know any of this, then maybe don't watch this video and come back when you do. A capacitor, let's say, stores electric charge. Unbeknown to many, a condenser stores electric charge and magnetic fields. Here we go. So, let's cut through some basics. If a positive charge is traveling, let's say, in this direction, it creates a rotating magnetic field up and out of the page. If a negative charge is traveling in this direction, it creates a rotating magnetic field up and out of the page that's opposite to that rotation, if they're both going in the same way, for example, right? Now, if a positive charge is moving down here, like we saw there, and it creates this up and out of the page rotation there, but if a negative charge is moving towards the positive charge, although it was a reverse rotation because it's going the other way, it creates a rotation up and out of the page which matches the rotation of this positive charge. So, let's step through this. Today's capacitor. Now, what do we have? With today's capacitor, if we start to provide a positive charge and we've got moving positive charges moving in, sorry, I got a bug on me there, moving in this way, and as you can see by my little arrow, there's a up and out of the page rotation of the magnetic field there. But then the positive charge moves both this way and this way. So this is while it's changing, right? So, and while it's changing, it creates a current, and a current is the result of moving electric charges creating magnetic fields. So, when the positive charge is moving this way, up and out of the page, as you can see there, with the magnetic field. But when it's moving the other way, up and out of the page and downward, that way. So as the positive charge is coming in and charging up this plate, it's creating two different magnetic rotations, which summarize to be no magnetic field. Now, when there is a moving electric charge, and its field lines are pointing out everywhere, dielectric field lines, lines of tension, it automatically creates a movement of opposing charge in the other element. So when this positive charge is moving here this way, it induces a negative charge here moving that way. Sorry, I'm wrong. The positive charge is here and it's attracting in the negative charge. I got a mistake in there. So positive charge coming here, but it's attracting in the negative charge this way. And where were we? Where they're, here. And when they're attracted, they're creating a coherent rotation. So great, we've got coherence and coherence here. But because it's also going the other way on both, we've got coherence between the two. But if you look at the summary, the positive and positive incoherent with each other, and the negative and the negative are incoherent with each other. So again, the net sum of the magnetic field result is zero. So, and this, of course, serves its purpose for storing in the electric field beautifully. But why I say a condenser is actually a different component is this. When we drive a positive charge in here, Now, of course, at first, some's going that way and some's coming this way, like with the normal capacitor. But notice then, both sides take a right angle turn. And then we have positive charges running down here, as well as down here. And those positive charges create this particular rotation of magnetic field, and same on the other side. Interestingly though, of course, according to Faraday's laws, this induces a negative charge here being attracted to the positive, and its rotation, it's going the other direction, of course, so now its rotation matches this. So we have an addition. We have this rotations, and this rotations all adding together in the magnetic field, along with the potential difference in the E field between the two plates. Well, you can argue it's 4 or 2. So there's a fundamental difference here. The condenser stores in both the electric and the magnetic fields, whereas the capacitor stores only in the electric fields. This stores in both aspects, and it's behavior similar to this that I've been playing with to get extremely high energy outputs. 7.3, and thanks for watching.